Hello. In this video, I shall talk about composite functions. I need two functions at least to make a composite function. So I shall use this function fx. Okay, let me clear this up and write it down again. Fx is equal to x squared plus 5. Now remember that we need to specify the domain and the codomain. So the allowed values of x and the allowed values of the answers from this formula. So domain, I used x from 0 to 1. Codomain, let's see. I'll use 5 to 6. Okay, which was the range that I got in the last video. Okay. Now for the other function, I'll use the gx that I used before. Now gx is equal to 2, and I also need to specify a domain and a codomain. Right. So let the domain be, say, between 0 and 1 as well, just the same as for fx. Let's say the codomain is between 0 and 2. Now I want to think about a composite function f of g of x. I want to think about this composite function. I can easily find the formula for this function simply by substituting these numbers, these expressions. So gx is 2x. So this gives f 2x, and f is x squared plus 5. But now I have 2x in the place of x. So to find the expression, I should substitute 2x into the x here. So this gives 2x squared plus 5, which is 4x squared plus 5. So it looks okay, no problem, fairly straightforward. I got a formula for the composite function. It's fine. But I haven't talked about the domain and the codomain. And as we'll see, there might be a problem. Now to see what happens, let me get an idea of the range of gx. And it's if we can sketch a graph for gx, it would usually be easier to see what's going on. Okay, so let's say this is x, this is y, and I want a graph for gx. Okay, so domain 0 to 1, that's my domain, and gx is 2x. So it's just a straight line graph going from, okay, when x is 0, gx is 0, I have a point here. When x is 1, gx is 2 times 1, which is 2. So I have a point there where y is 2. And since it is a straight line graph, I can just sketch a straight line joining those 2 points. So that's my graph. And this is the domain. Okay, that's my domain. And this is my codomain. So my codomain happens to be also my range, the range of Gx. Okay, so this is also the range. Okay. Not always, codomain is not always the range, but it's just happened to be the case in this example. So the range here, 0 to 2, is the set of values. Alright, it's the complete set of values that you would get, that would correspond to all the x in the domain between 0 and 1. Okay, so that seems simple enough. Now let's come back to the composite function. You know what the composite function means? It means that starting from a value of x, in this case for gx, some value between 0 and 1, okay, we can calculate a value for gx. So let's say if I take a value here, then I find a corresponding value here, and then that value would then go into the function f. And that's what a composite function means. Now let's take a look at the domain for fx. The domain for fx is between 0 and 1. Now the gx, if you remember, goes into the x value for the function f. But you see from here, from the range of gx, that the range of gx is between 0 and 2. So it's possible for gx to give values up to 2. Alright, so this value can go all the way up to 2. But then the function f only allows value up to 1 for x, for the value of x that goes into the function f. So now, can you see a problem now? Right, gx can give values up to 2, but fx can only take values up to 1. That means that the domain of fx does not allow some of the values given by gx. So if it helps, let me for example, if x is equal to 1.5, then gx, if I use this formula, is equal to 2 times 1.5, which is no, 1.5 is outside of this domain. Okay, let me clear this part up. So if x is equal to 0.75, for example, then gx is equal to 2 times 0.75, which is 1.5. Now, can I then use it in here for the f of gx? If I do that, I get f of 1.5. I can try and find an answer using that formula. The formula is not a problem. But the problem is that for fx, I'm only allowed values of x between 0 and 1. And now I have a 1.5 that I want to calculate for this composite function. So clearly the 1.5 is not allowed because this is outside the domain of f. So what this means is that this composite function, therefore, this composite function does not exist. Or that's another way to say that it's not possible, right? Or that it's not allowed under the way that I have set or fixed or defined the domain, the allowed values that goes into fx. So now you see that there is a problem. There is a problem. Fg actually does not exist for when f and g are defined, are functions that are defined in this way. Not just with the formulae, but also with the domains and codomains. So from this observation, we can actually write down a condition. We can actually find a condition for the composite function to exist. If you think about, for this example, if you think about why this fg composite does not exist, it's because there are some values of x that lie outside the domain of f. Okay, because this range of g, this range of the function g, is actually, some parts of it actually lie outside of the domain for f. So what this means is that we need the range to be completely inside the domain of f. We need the range of g to be actually inside the domain of f if we want a composite fg to exist. Okay, so let me write this out. For fg to exist, okay, the domain, not domain, range of gx must be inside the domain of fx. So that's the condition for the existence of fg.